Welcome back to NS4 Networking, the show where we break down big networking ideas into bite-sized episodes. I'm Holly Metlitsky, and with me is Ethan Banks. And today we're zooming out, way out, to talk about something kind of massive. We're diving into the vast world of WANs, or wide area networks. What are they? How do they work? How did we get from dial-up to cloud-powered internet? Let's unpack it all.
But you want to start a dial-up? Oh man, okay.
Maybe. I mean, what led us to discussing this topic was actually me thinking that we discuss SD-WAN. And I started doing some research and very quickly realized that jumping into the topic of SD-WAN without setting the stage of how we got there and how the world of networking developed or what is WAN might cause some problems. So today I'd like to have a little bit of a history lesson about the development of WAN, what went right, what went wrong, and how it's kind of changing over the years. So that's the stage. And let's start at the very beginning, or maybe not the very beginning, but just the beginning of what exactly is WAN, right? So to me, or what I like to think of it as, is obviously a wide area network that tends to connect smaller networks, so LANs, and typically covers, if we're looking at, a public WAN, covers large geographical areas. So Ethan, seeing as maybe you are around a little bit closer to the creation of WAN, could you give us a little bit of background how this all came about?
Thanks for that dig into my age. I appreciate that. Just because I'm old enough to be your father doesn't mean... Okay, it does kind of mean I'm old. Okay. So you hit it right. It's the geographically distributed network. So if you got a LAN, a local area network, it's like stuff in your building or stuff in your campus where you're pretty close together. Things aren't very far apart at all. You're hundreds of feet apart, hundreds of meters apart, maybe, not miles or many miles away. I don't know if there's a clear definition of, like, if you're this far away latency-wise, now it's a WAN. But I think to me, a WAN could include just going across a city. So, for example, I used to work for state government, and in the capital city of Concord, New Hampshire, we had fiber running around the city to connect up a bunch of different campuses that we had. We had 3 major campuses. Was that a WAN? Yeah, that was a wide area network. Sure it was. They were 3 different campuses with fiber runs of many miles to interconnect them. But then I also worked at a company where we had a global wide area network, where we had people that worked for a company in India and in Vietnam and in Germany, and we were headquartered in southern New Hampshire and interconnected all of that and so on. So I think that's a good definition of WAN. As far as that goes, it's just when you're connecting networks that are far apart, you're connecting LANs together. The internet is a kind of WAN, I think. You could think of it that way. Remember we talked about the internet as a network of networks, right? I think a WAN is that way, except it's your network of networks interconnected.
So I guess, would you say that the internet was kind of the first WAN?
Yeah, if you go back through internet history, there were college campuses, there were state or federal government sites that were interconnected, and they were far apart. And part of the magic of getting them connected was defining the protocols and packets and how are we going to actually exchange data between these sites. So yeah, I think the internet could fairly be described as the first WAN. I don't know. Were there other WANs that existed before that? I don't know with any certainty that there weren't, but the internet certainly comes to mind as the most obvious one, if not the very first.
This maybe is a little bit off the topic of WAN specifically, but when you start thinking about this, there's a lot of logistics behind actually physically building a WAN, like all the cabling and everything else. How do we get that done? Who owns that infrastructure? What does like the logistical side of building all of this out look like?
Didn't you just ask a big question there? Oh boy. So all the cabling and stuff when you have a campus, your own infrastructure, you own that cabling typically, right? You're the one who's going to run the fiber optics and the copper and stand up the wireless access points and so on. You own all of that. And as soon as you leave the building, you don't. And so you've got to lease the lines. Where did the lines come from? Historically, in America anyway, from the big telcos, from the big the telephone companies. They had laid over a period of decades and pushing into a century, all kinds of wire cabling infrastructure all over the world. And that will form the basis of a lot of the early wide area networks. We were running over that copper infrastructure or that fiber optic cabling infrastructure laid down by telcos. Now, again, I don't have a perfect timeline here. I don't have perfect history. That's not all in my head, but I can tell you that a lot of fiber optic infrastructure was laid as well, and not just by telcos, but by other interested parties. And it gets interesting because just going back to, I was telling you, I operated a WAN in a city in Concord, New Hampshire,
Hmm.
right? Even though we were state government, we had to get permission from the telco, the incumbent local exchange carrier, the ILEC, incumbent local exchange carrier, to run fiber because they're the ones, the telco were the ones that owned the poles or might have owned the right of way under the streets and so on, so that we could put fiber in ourselves. So we became our own fiber provider with an agreement and permission of the telcos to use their right of way, to use their poles, as the case may be, and run our fiber. Um, and so if you dig into WANs and history, again, in America, I don't know in Europe if it was significantly different or how that might have laid out. A lot of governments have been engaged over the years to provide wide area networking connectivity, the pathways, the fiber, to supply a network that different folks can use. But in America, again, it was leaned heavily onto the telcos, and we could get into a history of Bell and the breakup of the Bells, and that became AT&T and several other companies and so on. And without researching that, I don't know. I didn't know you were going to ask me this. We're really going back, but but I guess where I'm going here is on top of the telcos laying their own infrastructure over the years, there's been a lot of private companies that have laid fiber as well. There have been a lot of governments that have laid fiber and copper plants as well. You may have heard of municipal broadband. That's a movement where a town or a city will lay fiber in its own city as a service to the community, and they'll operate it themselves because they believe they can do it cost effectively. And most often they're right. There's been a lot of studies that demonstrate that. Um, and so I guess the ultimate answer to your question is it's a hodgepodge. It's a mix, and it's really grown and morphed over time. There have been folks that have just gone into it on their own because they saw an opportunity to put that infrastructure in and make some money. There have been governments that have funded this for purposes of the betterment of a society, and everything in between, and then you've got, of course, the massive cloud providers that have laid wide area networking cable, fiber optics all over the world, across the oceans, etc. Like Google, they made an announcement just this week as we recorded this about Cloud WAN, their Cloud WAN service. You want to connect your different data centers together around the world, well, you can use Google's network to do that now if you want with their new Cloud WAN service. So it's all over the place, and there's been billions. I don't know if trillions would be an exaggeration, but certainly billions of dollars invested over many decades to put copper, and then now lately, well, decades, but still lately, fiber optic cable to interconnect and add capacity globally. I hate that
So if
you asked.
we,
Can I just say, I feel bad.
yeah,
You ask me these questions and then they're really long answers. I'm sorry.
that's okay. I mean, that's what I want. I said this would be a little bit of a history lesson, so I need all the knowledge that is in your head. Maybe I can learn some of it. Um, but so if we're thinking about an enterprise, right? Now you've got your WAN, you've got your LAN, you've got your data center.
You know,
So Is it correct in me like visualizing this in the sense that your WAN is kind of like the edge of the network connecting what I don't want to say inside because that's like not the right terminology to use, but it's kind of like, let's say, the edge of your network at each location that allows
Yeah.
those to connect.
Yeah, I think that's a really good way to think about it. It's the edge. It's the perimeter. It's the boundary point of your LAN. Your to connect from your LAN elsewhere, you've got to go through some WAN to connect somewhere else. If you don't have a wide area network, you're still connected to a WAN of a sort because of the internet, right? You're
Yeah.
almost certainly going to have your network connected to the internet. The edge of your network is a boundary, probably a firewall that is then connected to the internet, to some kind of a service provider. And the same thing with your wide area networks. If you've got, I don't know, 3 campuses, let's say, spread across North America, at the edge of each of them, you go from LAN to WAN. There's a WAN router, perhaps, that is the boundary between the two. On the one side is your LAN with an Ethernet hookup, and on the other side is, in 2025, probably another Ethernet hookup, but it's
Hmm.
facing your service provider that is getting you from where you are to those other locations.
So, as you mentioned there, you could, in theory, just have a LAN and pass traffic from LAN to LAN over the internet, right?
Hmm.
Might not be
Sure.
the most optimal way because you're relying on the internet now. You don't have any dedicated cabling, I guess, that you're leasing. So, what is the use case for having your own private WAN? Because I can imagine that's quite expensive.
Hmm. In in the modern world, increasingly, it is difficult to make that case. The answer used to be you get dedicated bandwidth, dedicated
Yeah.
just to you. And so you're looking for some kind of reliable performance that's predictable. You'd go to your telco and say, "Hey, I need a circuit to connect to my global WAN that you guys are providing for me, and here's the new location." And you give them that location. Uh, but what's happened over the last 10 years, especially, internet bandwidth has climbed up so that you have so much bandwidth that comes into a site now from the internet, where it used to be not great. You had some kind of, I don't know, whatever the circuit was, just not that many megabits per second. And to get it just wasn't enough pipe to be able to push a
Yeah.
meaningful amount of traffic through it, perhaps. But that's all changed now, where it's like you get way more bandwidth from the average internet circuit than you could from a carrier, and it's good enough. Um, and so in 2025, what is the use case for a private WAN link? Um, I think it's less about performance and more about you have other needs that are driving this, like data governance.
Hmm.
You're not allowed to have any of your traffic pass through any country other than your own home country, let's say, or it definitely can't go through China because reasons, or Russia, et cetera. And so you're laying in a very specific network that controls how your traffic is going to flow as it moves around the globe across your wide area network. You're very particular about that. Um, that would be a concern. I suppose there are some situations where you're exchanging data with a business partner and the internet doesn't give you either the privacy that you're looking for. You can, even though, I mean, you're going to use an encrypted tunneler for sure, but maybe there's just very specific reasons because of the nature of the business relationship. You want to have a totally private connection. So I could see doing it in that, where you actually bring that business partner onto your WAN. That's a thing that you can do securely, and you're going to rely on your business partner to, or your telco to secure that connection to your business partner in a way that you trust. Um, but I got to be honest with you, Holly. In 2025, I'm like,
Yeah.
I'm just not going to do that very often. I mean, I'll give you one more example. One more example, and that's cloud. So you're a really big consumer, and you're shoveling a lot of data between your data centers and, say, AWS. Well, AWS would be delighted to sell you a DX circuit, they call it, direct connect. That is a massive amount of bandwidth, up to 10 gig, I think. I don't know if they're doing more than 10 gig. They might be. I lost track. Oh, there might be a 100 gig option now. I've lost track. Anyway, but it's a direct connect from somewhere you are to their cloud directly. And by their cloud, I mean the space you're renting in their cloud, your VPC that lives up in the Amazon
Yeah.
cloud. And you want it to be private because it maybe it does give you a certain performance envelope you're looking for, or you're pushing so much data between the cloud and your data center, you don't want to run it across your internet pipes. It's just too much data, and you really need a dedicated pipe just for that purpose. So there's another example. I'm out of ideas. I'll
So,
shut up now.
so I want to get into like a little bit of the more technical side of it quickly.
Okay.
Kind of. So now we talk about like old school WAN, right? Now we've got to connect. I'm going to call them your WAN edges. What protocols or like how are we doing that from a like standardization point of view? And I'm sure like everybody has their own method and their own ways of doing this, but I'd like to kind of understand where it's, I don't know if you can answer this, but like kind of where it started from the most basic manner to like now I'm sure protocols and everything else have progressed and it's got a little bit more complex.
Two pieces to the puzzle. One is, what's the transport that you're using, what you're actually plugging into on the WAN
Yeah.
side? What kind of a circuit is it? And then what are you running for a protocol on top of that circuit? So layers 1, 2, and 3 we're talking about here, really. Um, layers like Ethernet frames, that's layer 2, right? We
Hmm.
have an IP packet, we got to get it across the wire. Well, what is the wire? The wire is Ethernet. Okay, we're going to take the IP packet, put it in an Ethernet frame, and then deliver it to the end destination across that Ethernet network. Well, what is the network that the wide area network provider is giving you? What is it? Back in the day, it wasn't Ethernet. That wasn't a thing. You were Ethernet on your side, and you were something else on the other side, and they'd give you, various kinds of circuits. Again, we're talking history here, but TDM, time division multiplexing, which are circuits you can still buy. Those markets exist. You can still buy a T1 or a T3 circuit in certain markets because that might be the best of what's available. Um, that's not Ethernet. That's that's a
Yeah. What
different
is
way
that?
to frame. It's a different way to frame that information and carry it across the wire. That works on it's a it's copper wire. It doesn't have to be copper. It could actually be wireless. It could be fiber, but you're breaking up the signal along a clock. You're breaking up the data into packets, not packets. I guess they'd be frames. But you're using clock timing to do it. And then in a conjunction with that clock timing, you can break that into different channels. So you could carry, if you're a telco, you might have multiple customers that you're carrying along a particular TDM circuit within your network, or you're me consuming that circuit, and I'm going to take all of the T1 and every channel that's on it, and send you traffic along it, and get a whole big whopping 1.544 megabits per second. Ooh, that's very slow by modern standards. It used to be a big deal. It used to be like, we're going to drop a full T1 into that site. Whoa, who's the big rich person who's funding that kind of thing? Because mostly you'd get a fractional T1. I'm only going to
Yeah.
take some of the channels that are on that circuit, and I'm going to get a 64K circuit or 128K. Some kind of a fractional T1. But that's historical. And my point would be mostly historical. My point would be, you used to buy a WAN router, and the interesting thing about the WAN router was it had Ethernet on the one side for your LAN, and then it was modular, so you could stuff a card in it that was whatever the carrier needed it to be, so that you could talk to them. You got to put a T1 card in it, or you need you need a MUX, some kind of a multiplexer
Hmm.
that can talk T1 and translate the signal. So kind of a modem, sort of a modem device. And or it was ISDN was another one. I don't remember what ISDN stands for anymore, but it was like, oh, are we getting the full ISDN 128K? Whoa, we're bonding
Whoa.
both ISDN channels. Woo-hoo-hoo, baby, we're gonna fly now, 128K.
I don't even know what
uh,
you can send on that.
I mean, again, today you can't, right? It's not, the
Yeah.
modern internet doesn't function because we've gotten pretty you, back in the day, you used to design a website to be able to load over very low speed links
Mm.
like that. Now, no one thinks about that. You just cram as much garbage into your web page as you feel like. All the ads, all the navigation menus, all the graphics, and just like, oh, eat it, take it, and we assume that our broadband is going to be enough to be able to handle all of that. Back in the day, that was considered bad behavior because the assumption was you're probably pulling this website in over a pretty low speed link, as low as dial-up, as you
Yeah.
mentioned earlier, where you'd use literally a dial-up modem, where you would dial a phone number, a modem would answer, the two sides would negotiate based on the quality of the connection between them, how quickly they could talk, and they'd settle into whatever that was. You hope you got, late in the game anyway, 56K, and you might have got something less. And for a lot of years, it was low as 9600 baud, and even that was speedy compared to the very early days where it
Wow.
was 300 characters per second, 300 baud, which was useful for basically typing. You could type across the link, and that was about all you could manage to get across it. That's way, 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 way early days. We're talking 80s, probably 1980s, maybe even earlier. Um, and those speeds and the technologies kind of ramped up over time. So I want it all around, but where we've ended up in 2025 is probably the WAN handoff you're getting from your carrier is Ethernet. They're going to give you an
Hmm.
Ethernet circuit of some kind, and it's just a question of, you handing me copper or you handing me fiber. If you're handing me fiber, what kind of a fiber transceiver do I need? Because they could be handing you single mode fiber or multi-mode fiber, depending on where they're distributing the fiber from, whether they've got a presence in your building or not, and a bunch of other things. I've been worked for companies where the telco had a room in our data center because we had so many circuits we bought from them. They actually built a POP right in our data center. I've been at other places where it was like sad and unfortunate, and you took what you could get, kind of thing. The ancient copper would give you something terrible anyway.
Okay, so after that very long explanation,
I
um,
did it again.
WAN edge to WAN edge, we're looking at whatever circuit is in between, right? So it's either you've got frames flowing between them. I don't know, would it be packets at any point? Probably not.
Yeah, it's still
Or
packets.
maybe,
IP
yeah.
is IP, and so it's
Mm,
just a question of how your IP packet is wrapped and unwrapped as it moves through the wide area network infrastructure. But yeah, it's absolutely still going to be a packet. So we talked about tunnels last week, and we mentioned
yeah, I was,
MPLS for. So yeah, your packet's gonna, no matter what the underlying physical transport was
mhm,
to get it from where you are at your site in your data center, let's say, up to the carrier, it's going to have an Ethernet frame wrapped around it, or it's going to have whatever frame wrapped around it. Might enter into a service provider network, let's say, that is based on MPLS, because they are providing a bunch of layer 3 VPN services out,
mhm,
one per customer, and they're going to put MPLS tags on it for you in your layer 3 VPN that makes your traffic unique and carries it distinctly from everyone else's traffic and moves it through the network. Your packet stays intact. It's just a matter of what kind of header or tunnel encapsulation or whatever is wrapped around it to carry it across the network. And then as it physically moves through, it may or may not be Ethernet. There are lots of other transports that are there, but it's still going to be that packet at the end of the
mhm,
day, just with a bunch of different wrappers put around it, depending on where it is in the network and what needs to happen to it to keep it private and secure and routed correctly to be delivered to the other edge, the other WAN router, where, as far as you can tell, it's just a packet again. It's just another
yeah,
IP packet, even though it got put into and taken out of a bunch of boxes along the way
yeah.
to get delivered to you.
So bringing in our previous episode, what is and what is not a tunnel, would you say that traffic from WAN edge to WAN edge is typically tunneled?
There's a real good chance it's been tunneled in some way or another. Yeah, there's a real good chance of that. If it grows across the internet, you've tunneled it. You
Yeah.
didn't, for sure, because you probably put it in an IPsec tunnel or a GRE tunnel or one of a bunch of other kinds of tunnels that it might have gone into. If it's going across a carrier's network, it probably has got an MPLS header on it or some other kind of a wrapper on it to make it unique across your across their infrastructure. Yeah.
Makes sense. So now you've mentioned MPLS quite a bit, and I don't want to necessarily, we've spoken about it a little bit in previous episodes, but from what I've seen, I want to say like legacy WANs typically seem to be using MPLS. I don't know if that is a correct statement, but that's kind of something I've observed from the private WANs that I've seen. Um,
Mhm.
and my other observation is I think we're moving away from that. Why? Why was MPLS perhaps the chosen protocol or tunneling mechanism, and why are we moving away from that? If any of this is true, just based on my observations, but that would be my question.
Uh, I I don't know what I think about MPLS being moved away from. There are definitely other ways that you can build a
Hmm.
service provider network and not lean into that. But I would be very surprised if it's like going away and everyone's getting away from it. There's definitely other
Yeah.
technologies there, but as far as I can tell, it's still part and parcel of because there's so many applications that a service provider relies upon MPLS technologies to deliver that service to their customers. I'd be surprised if it was just being, gone. But I don't live in that world, so maybe I missed the memo. But yeah, it's
Or maybe it's more not like we're moving away from MPLS per se, but we're moving away from like we discussed that private
you
WAN. So it's
well,
not,
you're not
you're not
gonna.
going to be
Yeah,
using
I would agree with
MPLS if you're
that.
not doing private WAN.
I would definitely agree with that. I would definitely agree with you. You're not going to be using, private WAN from an enterprise perspective, but
Mm.
you're probably not calling your local telco, Verizon or AT&T, whoever, and going, "Hey, I need a new circuit from a private WAN like we did 15, 20 years ago." That's not a thing. You've re-architected it, and so a couple of things here from it's a cost driver is first and foremost. Private WANs are expensive. They're just spendy, and telcos have struggled to drive the cost down to the point where they can compete with what has become a viable alternative, that is using the internet as your WAN instead. Why go to the service provider for your wide area network and pay whatever they want to pay you to drop a private circuit into your building when you already got the internet there and it's gotten so much faster? And the whole key here is the last mile. We talk about with wide area network last mile and middle mile and these kind of things. The last mile is getting to getting to your building, your infrastructure. Last mile circuits have gone up in bandwidth dramatically in the last several years. Fiber deployments have gotten rolled out all over the place, even in rural communities. I live in the mountains of New Hampshire. I have fiber to my house. I have 1 gig symmetrical data. Some company rolled in here and strung fiber across the entire town, and even me living in the backside of nowhere. Well, I literally, there's a mountain like right there. That's it. It's right there. I have 1 gig symmetrical fiber to my house now. That's just typical of what's happened. Again, I live in the U.S., so that's what I know the most about. So all of a sudden, it's viable to connect uh, your data center, your building, to other data centers and buildings across the internet, get pretty good bandwidth for a way lower cost than you were going to be paying trying to get a similar circuit from your local telco. And that drove a lot of
Hmm.
this. Now, even before the bandwidth coming from your internet service provider was so cheap and plentiful, we would oftentimes stand up a point-to-point VPN tunnel across the internet as a form of WAN to connect to certain sites. It's like, connecting you across our telco, that's going to be really expensive. And all we need to do is exchange files twice a month for some purpose. It's not like we're in each other's face all the time, moving lots and lots of data. Let's just throw up a tunnel and and done. And yeah, that would
Hmm.
work. Well, now that the bandwidth again is so plentiful, the natural inclination is just to go that model all the time. And to go to your SD-WAN uh, question, which I know we want to devote a whole episode to SD-WAN, and we should, but software-defined WAN makes using the internet as a wide area network easy and
Yeah.
secure, and you don't have to think about it very hard, because I was mentioning like, oh, we just stand up a tunnel between us and somebody else to connect. Yeah, it wasn't always as easy as that. It was always kind of a pain in the butt. I got really good at troubleshooting IPsec problems that because we couldn't get the tunnel to stand up. Yeah, it was cheap, but it was annoying too. But that's the big thing that's changed. It's a cost driver. It's just so much cheaper now to use the internet as your wide area instead of the expense of a WAN router and a circuit. Those routers tended to cost some money, and then the monthly charge of the circuit itself, and then whatever bandwidth or service level you got. I was like, eh. Oh, interesting point. In early SD-WAN days, there were some studies done that demonstrated the quality of the bandwidth you got from your internet service provider and your private WAN provider was not that different. And in fact, internet in a lot
Interesting.
of cases was even better. Like you would get worse service for your private spendy WAN circuit than you would for internet. By worse service, I mean higher latency, more loss, for less bandwidth and at a much higher price. And that was another thing that people were just like, really? I guess I'm just going to use the internet. It seems to be better. Oh.
Yeah. So when you're actually building a WAN, what are some of like, so you need, obviously you need a router or maybe a couple of them and a circuit at a minimum, right? Because I
Okay.
think
Yeah.
if we're talking like WANs sound fancy. I don't know what it is. Maybe it's just me, but when I hear like, oh, you've got a private WAN, like it sounds fancy and complex, but is it? I mean, like you're really just building like a point to point connections.
Yeah.
That's I've
It's at
definitely
the end of the day,
oversimplified it, but
you didn't. It's you have it. It's IP routing.
yeah.
The WANs, they're not fancy, but because they tend to be less bandwidth than your LAN, you end up with some unique problems tied to your WAN.
Hmm.
That is, your WAN circuit is probably a bottleneck, even when it's a big, like, 1 gig symmetrical pipe. It's still probably a bottleneck of some kind, and so you end up with some challenges there. So it's not fancy. If you look at a router, a WAN router, and you log into it, if there's anything unusual about it, it might be that it's got a special card in it for the whatever the interface is that's required to talk to the telco. If they're not handing you Ethernet, they're handing you something I would think of as more legacy. That might seem unusual, and they'll be like, "Oh, geez, I got to configure a T1 card." Okay. And there are some steps to like make it do the thing and get the clock signaling right and get the framing right, and all of that. It's not rocket science, and they'll tell you exactly how to configure it. Um, but again, even if it's internet, the problems come in, and it's quote unquote fancy because you're dealing with the problem of, I've got a 10 gig network, and I'm connecting to a 1 gig or fraction of a gig, 500 megabit per second wide area network circuit. When you begin moving traffic from a very fast network through a slower network, you have run into congestion. It's kind
Hmm.
of like traffic going down the highway, and then you need to exit the highway. It's kind of like you're getting off the exit. And if the exit is a lot slower, everybody's got to hit the brakes, and there's probably a stop sign at the end, and they got to turn right or left, and traffic can stack up. And in a worst case scenario, if you've got lots and lots of traffic, and you live in the New York City area, so I mean, you probably see this now and again, where traffic might stack up from the exit right back into the travel lane of the highway. Even that's
Yeah.
congestion. That's not a bad analogy for what can happen. And so some of the fancier stuff you might see on a WAN router is configuration to help cope with that congestion situation. And we'll call this quality of service, QoS, which is a whole network study domain that you can spend lots and lots of time in.
Which
Um,
is interesting because I was at a like Q2 kickoff yesterday and our AWAN guy said along this topic saying like you pretty much you can't do set up WANs how you used to, like just throw all the traffic and it goes.
Mhm.
Like now we're going to have to start looking at WAN optimization, and looking at things like
Mhm.
QoS is going to become more standardized because of this like congestion issue and the amount of traffic that we're passing.
Yeah, it's the amount of traffic problem is also a big part of it too. Um, your WAN circuit represents more latency. You're dealing with sub-millisecond latency on your LAN. On your WAN, you're dealing with uh, potentially tens of milliseconds, even occasionally hundreds of milliseconds of latency, and that can cause traffic to stack up, and cause more. Some performance challenges, or cause retransmissions, in a worst case, which exacerbates the problem that you're trying to deal with. QoS schemes help you manage the packets that have gotten stuck in the buffer because of congestion. The interface can only send the traffic so quickly. Traffic that's arriving more quickly than that because it's showing up faster than you can get rid of it. A QoS policy helps you govern what traffic goes next in that buffer, and they can get quite complicated as far as what your policies are, because you've got things, well, like, oh, it's voice traffic. We should prioritize that because voice traffic's got to get there in a timely fashion. So how do you identify what the voice traffic is, and then make sure that if there are any voice traffic packets in the buffer, that they get sent out the door first, times however many different traffic classes you might have. And then there's modern. That's like a historical way you would have set up your QoS. More modern methods include what you call active queue management, AQM,
Hmm.
where you're considering how long has a packet sat in the buffer, and let's make sure it doesn't sit too long. Let's kind of keep it moving, and it's a different way to think about how traffic moves through a buffer, and it's a different style, and there's different algorithms that are tied to that. You might hear of CODEL, CODEL. There's Cake in the Cisco world anyway. I don't know if Cake made it as a universal thing, but there's, again, just different algorithms and different ways to handle that traffic. And QoS policies, if you look at a WAN router and go, oh, it's fancy, you might be looking at QoS policies that's describing that if there's congestion, this is how I want you to handle this stuff, router. That can be interesting there. You might have some other security policies on that WAN router that govern all kinds of different things, but it could be security, just like filtering, or it could be your policy-based routing. Maybe you've got multiple WAN circuits coming into a WAN router. That's a possible scenario. I want this traffic to go across this line. I want this traffic to go across this line. I want this traffic to go across the other line. You can govern things in that way as well. And so a WAN router times other things, but I mean, the WAN router, it isn't fancy, but because of the faster to slower problem, and the fact that you might be trying to carefully control how traffic is getting pushed across the WAN, you can end up with a bunch more configuration code in that thing.
Yeah.
And again, going back to SD-WAN, a lot of that's handled for you, so you don't have to look at that. If you're doing it all by hand, artisanally, on your Juniper box or your Cisco box, it can make for a pretty long configuration.
My next question kind of comes from a maintenance perspective, because you think of your network and you don't really think about the interconnecting parts that you don't manage. What happens when something goes wrong on those like those circuits that you leasing, or the interconnecting
Yeah.
bits that you actually don't own? Because like sure you have your network, but there's so many moving parts that now with the WAN aren't in your control.
Yeah, yeah. The edge of your network, that WAN router, that firewall, whatever it is the last piece you own. The rest of it is someone else's that you own, and you don't manage it. You can't
Yeah.
monitor it with your monitoring software, and it's going to go through several different routers across potentially several different cities or around the world even before it gets to the destination. So when performance is terrible, what do you do? How do you know?
Yeah.
Um, okay, so a few different things here. One, there is a whole class of software called IPM, Internet Performance Monitoring, that can help you with this. So there's two vendors that are top of mind for me because they've been Packet Pusher sponsors over the years. One is Cisco Thousand Eyes. They make software that can see that can figure out what hops there are between you and the other WAN router via the internet, let's say. And they can tell you everything that's going on the internet, and they monitor the global internet in such a way that if traffic's slow and it's something that they monitor, they can tell you, yeah, it's this router in Virginia that is dropping packets like mad, and we can tell because of our test traffic that we're sending here and there, and it
Yeah.
started at this time of day, and they can give you all kinds of crazy stats. Or there's a BGP hijack in progress, and that is causing all kinds of routing headaches for IP prefixes that originated from the ASN that got hijacked. They can tell you all that stuff. So the other one is a catch point, is another one. So Cisco Thousand Eyes catch point, and there's some other people in that space as well. So that's a tool you got to buy to
Hmm.
give you insight as to what's going on.
But now you have that insight. I mean, it's not like you're going to call your ISP and be like, hey, I can see this router's got issues, fix it. I can't imagine they care very much.
Not if you're not their customer.
Yeah.
However, your ISP is probably their customer. And
Hmm.
so, you may or may not be able to get an action item for it, for this thing that you're observing, but you can go to your ISP and say, hey, I've noticed with my software, Catchpoint just spit me out a report that's telling me, this router upstream from you guys is like bad broke. And they're probably already going to know. They'll probably be like,
Hmm.
yep, it's you, and we've gotten 100 other calls today because of that router. That's upstream from us. That's a problem. So at least you can. Then if they didn't know, and they'd be like, oh, can you send us the report? You can share that report with them, and they may or may not care. They may or may not do anything about it. But in theory, you've armed them with the information to uh, to to take an action, to go forth and try to solve that thing. In a lot of cases, it's just wait and see. It's
Hmm.
not like most of these ISPs, they're going to be very good about monitoring things. They know they've got a router that's dying, out there and dropping packets. They're aware. They know, and it could be any number of things that they need to do to solve the problem. It could be a failing hardware, could be a bad circuit, could be they're in the middle of fighting a DDoS attack. Could be a lot of scenarios that could be going
Yeah.
on there. Um, and there's nothing for you to do other than say, boss, sorry, we know what the problem is, but it is beyond our control to do anything about it. And all you could do is try to come up with a workaround, maybe, if it's really going on for a long time. Can you reroute traffic around that some way? Through whatever means you've got within your control would be a consideration if it's really business impacting. Other than that, it's just like, nothing we can do. Just kind of wait.
Yeah. It's interesting because it's, you want to maintain full control of your network, but you never really do. So
No.
you've got to, learn to figure out how to. I guess the it always comes down to like mean time to innocence. Like all you need to do is pretty much prove that it's not you. It's not you. It's not our network, and from there you can figure it
Yeah,
out.
and that's true even on your LAN, right? I mean,
Yeah.
you're running a core switch that's got a memory leak, and you're actually monitoring memory utilization, and you're seeing it climb and climb and climb, and you dig through and you find out, there's an open bug on the code on my core switch that says if you're running this routing process, it's leaking memory, and eventually it's going to crash. That's also beyond your control. What are you going to
Yeah.
do? It's the vendor's crappy code that's causing the problem, and all you can do is say, hey, boss, I saw this problem, and we should schedule an outage to restart the router and hopefully upgrade the code to something that doesn't have a memory leak anymore. My point being, even on your LAN, you're probably going to be victimized by things that are beyond your control. It is part and parcel of being a network engineer. That's just the
Yeah.
way of it.
So we've discussed like typical WAN and what that looks like. And in our script notes, Ethan did a lovely, gigantic, long brain dump of everything WAN. And there was one thing that I want you to talk about. And it's, as he titled it, Modern Day WAN, if it was up to Ethan. Now, I'd love to
Oh.
hear your thoughts on this because, like, that's where I'm really going with this whole episode is, yes, we have private WANs and I don't want to say it's a thing of the past but it's definitely, like you said, becoming much more expensive to deploy that and to manage that. So What is Ethan's modern day WAN solution?
Right. And this, again, this is where I'd start. Any design or anything is always subject to what's the business need, and
Yep.
there's any number of mitigating requirements that could change what I'm about to say here. But this is where I would start until it becomes clear that this would be the wrong solution for whatever reasons. But I'm going to use the internet as WAN, number one. Now that assumes I've got uh, cheap, fast internet speed in my area wherever I need to provide service. That's going to be a thing. And maybe that's not the thing, because it isn't,
Yep.
not everyone's got the same internet everywhere. But let's assume I can do that, first of all. Then I'm going to use software-defined WAN. I'm going to pick some kind of a software-defined WAN provider and use that as my overlay to interconnect all of those sites together. That is, the internet becomes my underlay, and the software-defined WAN routers form a tunnel overlay on top of the internet, is how that's going to go. Now, that there's some reasons for that. Software-defined WAN is going to give me my data privacy, of course. I'm going to get encryption so that I can safely move that data, so that if it's intercepted across the internet by some bad actor, they can't do anything with it because the data is encrypted. It also gives me application-specific routing. Software-defined WAN has features where I can tell it, hey, if this is voice traffic, it needs to go across a tunnel that at any given time has very specific characteristics, very low jitter, very low latency, and no loss. Whichever line is the best at meeting those characteristics, send my voice traffic across that. And at times, however many applications I have where I care about the nature of the tunnel I'm putting that traffic into, software-defined WAN devices will monitor the health of those tunnels as in the mesh, and knows in real time where it should be routing traffic to. So I get those features, across the internet. So that, and the big deal here is the internet changes over the course of a day in a 24-hour
Yeah.
period, depending on geographically where things are, how many people are using it, circuits going up and down, various other things. So I need to be monitoring the health of those tunnels in real time, and then making routing decisions based on that constant flow of telemetry information I'm gathering from the tunnels. SD-WAN does that for me. I don't have to think about that, as an
Mm-hmm.
engineer. I write policies in the software-defined WAN solution. This is a bit romanticized and idealized, but that roughly stated, that's the value prop there that I'm going to get. So internet is WAN, software-defined WAN overlay on top. Um, I'm probably going to integrate my cloud presences, like if I'm in AWS, Azure, and GCP, let's say the big three. I'm going to integrate those into my WAN fabric. Probably. It depends a
Mm-hmm.
lot on the nature of the traffic I'm moving between cloud and any on-premise data centers I might have. But assuming that matters to me, I'm going to want a solution that can integrate all of that together, so that my cloud and my physical campuses and data centers can all be integrated on one big WAN, because I want to operate it as one fabric, and I want to control policy and traffic flow and security and monitoring and have it all be on one common management plane and data plane. That's what I would like to have. And again, that's a lot of SD-WAN solutions can offer me exactly that. There's a ton of them out there. We'll talk more about that in a future episode. So then the question is, well, what about the WAN circuits themselves? And there's
Yeah.
a bunch of things here. If I'm using the internet as WAN, I'm talking to my local ISP, and they're giving me my circuit, right? I've got it like I would order it at my house. I'm going to order it at my business instead. But there's another interesting class of offering out there called NAS, Network as a Service. And there's a bunch of providers in this space that have different specialties, but one of them is they offer you WAN, Network as a Service, with a click of a button. You go into the interface. Megaport is in this world, I believe. Packet Fabric is in this world. And they've got their own network built around data centers interconnecting across the globe. And you go, all right, I need to get from Paris to Boston. Okay. And you go in and we click, 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 and pew, they stand up a circuit. And assuming you're in the same data center that they are, you're all connected. I mean, again, I've oversimplified it a bit, but that's roughly what happens there. And the circuit doesn't take days or weeks to stand up. It takes minutes, and the circuit is up there because they're providing you, again, as a service. They built the infrastructure through a software layer on top of it so you can dynamically allocate private bandwidth just for you across their infrastructure. So I'm going to lean into someone like that very probably. Again, it depends on where am I in relation
Yeah.
to where they are. Am I co-located on Summer Street in Boston? Then I've got a zillion choices of providers that can maybe give me some kind of wide area network service. Am I at SuperNap in Las Vegas? Same kind of story. Manhattan, a million options, right? Depending on where physically I'm located. If I'm on some no-name building, on the backside of the city, on the edge of town with poor fiber connectivity. No, probably not. Last mile becomes a problem in that
Yeah.
scenario for me. But where I can, I'm going to lean into, Megaport, Packet Fabric, these sorts of vendors to give me a network as a service so I can dynamically stand up and tear down a wide area network service. Which kind of goes to my last point here. I don't actually want my own data centers by and large, not in 2025. If I've
Yeah.
got them, fine, but why? I would way rather have all of my compute, my heavy duty servers, things that are providing applications, co-located in some SuperNAP facility or wherever, some big Equinix, some big data center provider that's what they do. They make data centers, and they're going to be delighted to rent you some space in their data center. So you've got great power, you've got incredible network connectivity, and yeah, that's what I want. I want all my compute there so that the
Yeah.
only thing I really got to worry about connecting are my campuses where my physical people are that are sitting in the offices getting work done, doing development work and so on. And we didn't talk about remote access. That would be another part of this, but that's like you and me working from the coffee shop, kind of thing. We can
Yeah.
talk about that stuff too, but that kind of rolls into the whole SD-WAN solution as well. ZTNA, Zero Trust Network Access in 2025 language, tends to fall under that very broad heading. Well, in fairness, that would be the SASE heading, Secure Access Service Edge. You heard of that acronym? I'm sure you have
Yep.
because of what your job is, but yeah, so under SASE, you have SD-WAN and then remote access services like ZTNA. So you're delivering a whole service here in that your WAN isn't just all the physical locations. It's also,
Yeah.
where'd Holly pick up her laptop and try to connect to the network today? From your favorite Starbucks in Manhattan or something. And how do I securely connect you in and give you good performance and security? And all of that. Again,
Yeah.
that's a whole other discussion yet again, VPN services, ZTNA, and all that kind of stuff, but comes under this broad WAN heading.
We'll add it to the list. But I've really enjoyed this conversation because we've gone from like typical WAN back in the day to ideally how you would build a WAN today. And I think those views are different and they've definitely
Yeah.
changed and the requirements and feature sets have changed a lot.
Mm.
So now we've got SD-WAN, we've got all these cool features, but we've also got like these LEO satellites that have now started coming into play.
Yeah,
And
yeah.
I mean, I'm asking you what's going to happen there. Like, no, you can't really predict the future, but how do you think that that's maybe going to change the world of WAN, if at all?
LEO satellites, so as in low Earth orbit
Yeah,
satellites. Satellite communications used to suck because the satellites were so far from the Earth's surface that the latency was just astonishingly high, and you only really could use them for certain special purpose things. LEO satellites are so close that the latency isn't bad at all, very usable for all kinds of different services. And can, over time, as more and more of the satellites are launched and the constellations grow, Starlink, Blue Origin is putting up their service. It's got a different name. They don't call it Blue Origin. Anyway, they've got their own
yeah,
constellation that's going up. Kuiper, Kuiper, maybe that's it. And then there's some European services. They're putting satellites up for all these kind of services. We are going to cover the globe with satellites that aren't that high off the ground from a latency perspective, so we can bounce signal up to them, back down to a terrestrial relay station, and have useful WAN. The problem is, in my mind, bandwidth. The more
Mhm.
people that are using the satellites, because they've only got so many communication channels at a time, the more it's kind of like a cell tower, or kind of similar problem as you would have with a wireless access point, where you can have great signal, but the more people that are trying to use that signal, you can crowd the available channels and make it increasingly difficult to get traffic through them. So, will Leo be useful as a wide area network link, that a business would like? Oh, I could go with my local ISP over cable or fiber, or hey, what if I just use Starlink? I don't I think that's a great big it depends whether or not that's a
Yeah.
viable solution for your business. You also get varying amounts of bandwidth to back and forth to the satellite depending on weather. If it's really raining hard, that can definitely hurt your signal. If you don't have clear path to the sky because you're beaming through trees, depending on where on the horizon the satellite is flying overhead, that can impact your throughput and capability and latency and all of that. So it's a different sort of offering that depends a lot on your location, where you are on the Earth, and what angle the satellites are to your location on the Earth. You like, I don't think you can get Starlink at the poles yet, not North Pole or
Mhm.
South Pole. I don't think the way the orbits go, I don't believe that's a possibility, and or there's just no terrestrial relays for the satellites to beam
Yeah.
down to for that coverage. Possibly, although the satellites, like in Starlink, satellites do beam messages to each other as they are orbiting so that they can get to a terrestrial relay. But I still think that where the ground relay stations are a potential architecture challenge. So, a long way to say it's really cool. It's going to get better and better as more and more satellites go up in the air and as more competitors enter the space. Yeah, the space and space itself. Uh, will it replace land-based lines? No, and in fact, it doesn't
Mhm.
replace land-based lines. But for places where there is no infrastructure, uh, like we talked to a guy who's up in Idaho, which, if you're not from the US, the northwest part of America, where it's very rugged mountainous country. And he was, his ISP is a wireless ISP that was servicing a small town on the far side of a mountain that gets cut off because of snow, potentially, or other geographical challenges or infrastructure problems. Starlink's his backup for that town. He can keep that town online with a backup Starlink connection. And he talked about exactly how he built it and did it in one of our heavy networking episodes earlier in this year. We published that. I believe that was early 2025. We published that story. Super cool. Those are the use cases that make the most sense to me as opposed to a primary. But last
Mm.
note, I know Starlink provides if you are interested in like a massive amount of bandwidth from them, you can work with them if you've got the money to do a terrestrial downlink from them. That's a huge amount of bandwidth. That's a thing. But I think you got to be, either like you're an ISP wanting to build
Yeah.
this thing for service, or you're some huge company where I think you're into, I think, a low 8-figure spend. I want to say it was like 10 or 12 million or something to get started with that install. But
Mm.
Starlink would work with you to build a terrestrial downlink station for that, as I recall. It's been a few months since I read that article, but I was like,
Very
okay,
interesting.
yeah,
Me and my pocket change, maybe I'll contemplate it.
yeah, yeah. Yeah. Let me know how it works out.
That's very cool, though. It's so interesting to see how things have. I mean, if you think about the timeline of, like, I don't know, when the first WAN was created or the internet was created to where we are now, it's not that much time for how much things have evolved. I mean, I
Not
think in
really.
my head, at least, it's not that long. So it'll be very
No,
interesting to see.
no, the technology keeps advancing to what we need, but more is the infrastructure rollout,
Mm,
and getting more and more and more and more fiber out there, so we're no longer dependent on copper, which forever was the bottleneck for both bandwidth capability and quality. The amount of fiber that's been rolled out, not just in America but around the world, has just changed everything. Yeah.
yeah. Well, I hope that Firstly, I hope we've satisfied all the topics in your brain dump, Ethan. We've touched, I think we've touched all of those unintentionally.
I mean, there's so much more history we could get into. We could talk about modems and dial-up back in the
Yeah.
day, and we could talk about get into detail about TDM, which somebody actually wanted us to do it because they're in the
Yeah.
European market where they had T1 E1 circuits and wanted to know, like, what the heck is TDM? Maybe we do a show on that at some point, since it's still relevant in certain markets as old as it is. I don't know.
I did see that comment, and I had to go and like figure out what TDM was because I'd never heard of it before. So yeah, when we get to like all the other topics, maybe we'll add that to the bottom of the list. I don't know how many people still use it, so I don't know how
Enough for it to come
relevant
up
it
as a
is.
question, so I guess somebody does, right?
That's true.
No,
That's very true. So we'll it's on the list. We'll leave it at that. But
it is on the list. Yeah.
I hope that this episode has helped our listeners wrap their head around the wonderful world of WAN, or perhaps refresh your memory if you've been around for a while. And if you have any topic suggestions for future episodes, let us know. Add it to or post it on packetpushers.net/follow-up. You can also find Ethan and I on LinkedIn or the Packet Pushers community Slack group. The group is a great place to connect with other networking nerds. I love it. I've learned so much just reading through other people's comments, so highly recommend joining. And if you'd like to watch our pretty faces instead of listening to us, head over to N is for Networking on our YouTube channel to change it up a little bit. Thanks for listening to this episode of N is for Networking. And of course, just remember, networking isn't hard. Others have figured it out, so you can too.